This video we will learn how to draw Lewis structures. We'll first learn a little bit about them. I'll give you some hints on how to draw them, and then I'll show you. The best way to do these is just practice. If you like solving puzzles, these tend to be fun, enjoyable. If not, you'll have to learn to love them. Really, it is just a puzzle. We'll go back to the dot structures, and you got to figure out how to piece the atoms together to make a structure that works and satisfies the valence electrons of every atom involved. So, the definition of a Lewis structure. It is a structure that shows all the bonds, lone pairs of electrons, and all the atoms in a compound. So it's a way to draw them and to model them on paper. This only works for covalent compounds, and we got to make sure we show all the valence electrons. It uses symbols, lines, and dots to represent the compound. So this is a nice crude way simple way to just kind of start seeing the shapes of compounds and understanding how they behave and how they look. Obviously, this isn't a 3D model. The molecules are actually three-dimensional. You would learn more about the 3D shapes in college chemistry. Okay, so there's a few different types of bonds. The first one is a single bond. Then we've got double and triple bond. Pretty simple names there. You can probably figure out that a single bond is one pair of electrons. A double bond then must be two pairs, and a triple bond is three pairs of electrons. And we draw them like this. A single bond, single line. Double bond, you got a double line. Triple bond, you got a triple line. So it is possible for atoms to share more than one pair of electrons and form a double bond with each other. It is also possible for them to share three pairs of electrons, and we call that a triple bond. A triple bond is stronger than a double bond, and a double bond is stronger than a single bond. And because this is one pair of electrons, it represents two electrons, so one pair. You got two pairs is 4, and three pairs is 6. We do have to do a little bit of accounting with the electrons and keeping track of them, so this is a good way. Each line represents 2 electrons. So if you've got 3 lines, 6 electrons. Now there are steps. I'm going to let you write these down. So pause this, write it down. And now the steps, first of all, use a pencil. You're going to get halfway through and realize, shoot, I did this wrong. I'm going to have to erase it, rearrange the atoms a little bit. And it's important to use a pencil so that it stays neat. Now, the second thing you got to do is figure out how many atoms there are in the compound, how many of each type of atom. You'll do that from the formula. Then you add up the electrons, the valence electrons. Sometimes refer to that as the magic number of the compound. How many valence electrons are you working with? So make sure you're familiar with that word if I say magic number. And then arrange the atoms to form a skeleton structure. So you give each atom a bond for each lone electron. So I'll come back to that point in a second. Some other hints. You place the atoms with the greatest number of bonds in the middle. So I mentioned that each single electron will form a bond. So when you draw the dot structure, remember you put single dots. So let's actually go back and refresh here. We've got an X. The first dot go here. You have one dot you got to put somewhere around here, right? The second dot, third dot, fourth dot, they've got to be single. Now the fifth dot would go here, 6 here, 7, and 8th would go here. Now double dots don't form bonds. The pairs do not form bonds, but if you have a single dot, that single dot needs to find another single dot somewhere else. So the atom with the most single dots, which is carbon will always have 4 valence electrons, so it has 4 single dots. It forms 4 bonds. It will always be found in the middle of a structure. Try to make it symmetric. Nature likes symmetry for some reason. So if you can make it symmetric, that tends to work well. It doesn't always, so don't say, there's no rule that says it has to be symmetric, your structure. But making it symmetric sometimes makes things easier for you because it tends to work more often than not. Hydrogen is never in the middle because hydrogen looks like this. It's got 1 valence electron, it forms 1 bond. That means it makes 1 bond and it's a dead end. It doesn't form like chains or anything like that. It just kind of sticks onto stuff along the outside. Hydrogen is a dead-end molecule, or a dead-end atom, sorry, not molecule, atom. And then you cannot form a 2 or 3 member ring. So what I mean by that should be a 3 or 4 member ring. So you can't form carbon like this. You can't make a triangle out of it. You also can't make a square out of the carbon atoms. You can't bond them in a square. But you can bond them as a pentagon or a hexagon or even an octagon. Because the bond angles here are too sharp, the carbon would never make this bond. Same thing here. Carbon can't make 90-degree bond angles, but a pentagon, these are acceptable angles for carbon to make bonds, and same thing with hexagons. Some more hints. Each bond represents 2 electrons. We already talked about that. The number of lone electrons is equal to the number of bonds the atom will typically make. So like I said, carbon has 4 lone electrons. It will end up making 4 bonds. H is happy with only 2 valence electrons. So the rule is you typically got to make all the atoms have 8. So like carbon, after it shares, each bond represents 2. It thinks it has 2, 4, 6, 8. But hydrogen's happy. It'll share, make 1 bond. It's happy with 2 because 2 is like helium, right? It thinks it's like helium. It thinks it's a noble gas when it has 2. Most atoms need 8 though, as I already said. So write those down. Here's our first example. So the first thing you got to realize, how many valence electrons are in this? You look on your periodic table, you go to carbon, you go to the top of the periodic table, and you find that carbon has 4 valence electrons. Then you go to hydrogen. Hydrogen has 1. Now there are 3 of them though, so you go 1 times 3. And then we're going to add these together. And then you look at iodine. Iodine has 7 valence electrons. So if I look this up, carbon brings 4 valence electrons. There's 3 hydrogens that each bring 1 electron to the table. And then iodine brings 7. So if you add this up, 4 plus 3 plus 7, this compound has 14 total valence electrons. So this would be what we call the magic number. Oh, I screwed that up. Magic number, or the number of valence electrons. Now the next thing is I'm going to draw a dot structure for each, and I would recommend this at first because at first you're not going to be as good at quickly identifying how many bonds something makes, but once you get good at this, you'll probably skip this step, to be honest. So carbon has 4 valence electrons, so I put 4 dots around it. That means that it's going to form 4 bonds. So 4 bonds. And you don't have to do all of this. This is just illustrating it to you the first time. Hydrogen has 1 valence electron. It has 1 single dot, so it's going to form 1 bond. Iodine has 7 valence electrons, but notice we got 3 pairs. They don't do anything. There's actually only 1 dot, 1 single dot. So that's going to form 1 bond as well. Now, all of those other hints, you can check them as you need to, but the 2 that I really think are important are, number 1, if it has more bonds, start with that one. If it has less bonds, save it for later. So go in the order of most bonds to least bonds. I look, okay, carbon has 4. I'm going to start with carbon. That goes in the middle. And then if something, let's say there's another atom that forms 2 bonds, I would do that one next, and I would save hydrogen and iodine till the end. However, hydrogen and iodine, they're equal. They all go at the end anyways. Now, rule number 1, carbon in the middle, most bonds. Rule number 2, every single dot needs to find a buddy. So I draw the single dots. Carbon has 4 single dots that need to find buddies. So we got to find buddies for them. Now, I've got 3 hydrogens. I'm going to take one of them and just stick it right here. Hydrogen has 1 dot that needs to find a buddy. Now, the rule with these single dots is they have to find buddies from, they have to find another single dot from another atom to buddy up with. So this hydrogen dot wants to partner up with the dot from carbon. So I draw a line to represent a bond. And remember, the bonds represent 2 electrons. They represent 2 electrons. And now this hydrogen thinks that it has 2 electrons. This carbon now thinks that it has 1, 2, 3, 4, 5. So this carbon thinks it has 5. It wants 8. So we've used 1 hydrogen. Now let's just take another hydrogen. Okay, this single dot wants to find a buddy, so it finds it becomes a buddy with this one. And I'm not doing this the neatest here. I'll redraw it cleaner here after we're done. I've got 1 more hydrogen, so I put a hydrogen down. It's going to buddy up with that dot. So that's how that one bonds. So now I've used my carbon, all 3 hydrogens. I've just got my iodine left. So I'm going to assume that it goes here. 1, 2, 3, 4, 5, 6, 7. And then obviously this one needs a buddy. There's 1 left for carbon. So they team up. So now this is the kind of rough sketch of the Lewis structure for this compound. What I would recommend, or sorry, not recommend, a few pointers that kind of bother me that make sure that you don't fall into this trap. A lot of students will draw a bond like this. When they make the bond between like this carbon and hydrogen, they'll go like this. I don't like that because these 2 dots become the bond. These 2 single dots become the bond. So I want you to make sure that those dots become the bond. So you might even want to erase the dots. You'll have 2 dots here. Erase them, then draw the line. Or if you end up like doing this really sloppy like this, just take a second, redraw it if you need to. However, when you redraw it, a common mistake to redrawing is you do all this, you're forgetting something important, and in this case you're forgetting the extra double dots. They don't do anything, but you have to show them. And you might be like, well, why do I have to show them if they don't do anything? Well, in this class, you don't really get that advanced to really understand the reasoning, but in college chem, the double dots don't bond, but they do affect the shape of the molecule. So you would figure out kind of why you keep the double dots around when you do Lewis structures. So then this would be my final answer. Now I always should double check, do my electrons add up to my magic number? So let's count here. Each line represents 2, so I go 2, 4, 6, 8. Then I've got 10, 12, 14. The reason I recommend counting them up when you're done and checking back to this number is because if you forget any of these double dots, this last step check will definitely expose that mistake if you forgot. So a couple rules when you're done. Every single dot needs to have found another single dot to pair up with from a different atom. If you have any single dots left over, you have a problem. You do not have a correct answer if there's a single dot left over. Also, you need to keep all those double dots, so make sure you carry those over. Make sure your valence electrons match up. And don't make any squares. Don't make any triangles, like I had mentioned before. And there's one other rule I'm totally forgetting. I will make sure I include it in the next video as we go on, because it might be one of the more advanced Lewis structures, and it'll be more relevant then. So I will leave it here. Try the next one on your own, but the next example in your notes will be in the next video, and I will resume with you then.